Hey, welcome back. Hope you're all well. Good to see you again. Thanks for joining the channel. And look what I got on my bench. It's like a 35-pound lump of suitcase. But it's not a suitcase. It is a piece of history from the 50s. It is a phonograph. And it is a stereo one. And it's a high fidelity stereo one, phonic. So this has got some good features. Back in the day, these were your hi-fi. This is what you got. And yeah, it's a nice little rig. So this was brought to me by one of my clients. He found it and he liked it, and reminded him of his youth. And thought it would be good for bringing this thing back. So he brought it to me to have it checked over. I don't know anything about it. I don't have any service data. I don't have any information on this. Really unique. It's got speakers, stereo speakers, one on each side. So you flip these forward, right? And you can drop your album on, play it. These also detach. They lift off, and they have some cord. And what has it got in there? Probably about a 6 or 7 inch speaker. And that's, you can place these off to the side to get more separation. And yeah, it was quite the thing. And this thing's pretty heavy. Like I said, it's 35, actually it's about 32 pounds. And it was built back in the day when manufacturers didn't care about weight. You know, back in the 50s when they built the cars, you know what they all looked like and what they weighed. But this is the same thing. It's all steel case, a little bit of aluminum trim for aesthetics, but it's all steel, and it's all heavy. So what it has a stereo amplifier in it. We have volume control, minimum, balance for left and right, and a tone control that just gives you the choice between either heavy bass or high treble. A floating suspended turntable. Looks like it might be locked down in this one corner here. It is missing the 4 to 5 adapter, which is unfortunate. And then this is a record changer. So I think it is something automatic going on here. It doesn't really want to spin too good, so we'll get into that. But yeah, let's check this thing out. Let me plug it in and see what it does. Speed selector. Okay, give me a second here. Okay, let's plug this in. Power switch is here. It says off, on, and reject. I don't know if that's on. There's no switching here. This is a speed selector, so there's no other power switch. So let's plug this thing in. Ouch, and I got a little shock from this. We're drawing about 35 watts, the motor's going. Left speaker. Right speaker. 37 watts. Okay. So that right there tells us what we need to do. Typically on these tube amplifiers, electrolytics are a problem, and this one is no exception. I did get a shock when I touched this buckle. That is another problem we have to address. I don't know if that's something going on with the amplifier. I guess it is. And a third problem I noticed is we have no stylus on this thing. There's a stylus missing. So I don't know what I'm going to do about that. Okay, first thing I want to look at is this electrocution problem here. So let's plug this in again. Because I did get a zap off of it. And we'll check for between ground and the case. And we're getting 2.1 volts, okay? Let's turn the plug around, plug it back in. ground in the case. Oh, look at that, we're getting 120 volts. Okay, between so we're getting 120 volts between the steel case of this thing and ground, so that's not good. And I think a part of the problem is, part of the big problem is we probably have a capacitor, depth capacitor to ground, to the chassis. Another part of the problem is we have a power cord that has an end on it that has no polarity to it. So do we scrap this and put a polarized plug on? I think we might have to, because 120 volts on this metal cased device is not cool. And yes, I did get a shock off of it. It was not a strong one, but it was, you could actually feel it. So all right, here's a look at the back. Take this cover off. We have the power input here, a little socket. Let's take this back off and see what's inside. Heavy steel back. All right, I got some wiring. These are speaker wires. That's for that side. Where's the other one for the other side? There is a, here's the power input, and that seems to go to the turntable. Up here we have an area where it's power amplifier, and you can see that there's 3 tubes. Here's a filter cap here, 2 output transformers, and a little box that has probably resistors and capacitors in it. So I think if I take this screw and this screw off, I think the amplifier will come right out. And just a matter of disconnecting it with these wire nuts, I'm assuming. And then this sad looking capacitor right here. Let's take this off. It is a wax encrusted electrolytic. It actually has 3 capacitors in there, 100 at 150, 50 at 150, and 60 at 10 volts. So we can replace that easy enough. Let's try removing the amplifier itself. Get this disconnected here and here. Okay. Let's remove this screw. Okay, so that loosens the back of it, but it still doesn't release the front. I think I might need to remove some screws from the front and pull the knob, so I'll shut the camera off, we'll do that. Here's a picture of the tube complement. Got 2 output transformers, 50 DC4, 35 EH5, 35 EH5, so those 2 are your outputs, one for left, one for right. 50 DC4 is probably your rectifier. And yeah, it's just a basic amplifier. Crystal pickup, which is a high level output, and it doesn't need as much amplification as the magnetic ones do. These knobs are cast metal. They're very heavy. They're probably made of zinc or pot metal, but plastic shafts. Maybe that's what they're relying on for insulation. I don't know. But yeah, there's no fear of this thing weighing too much. Okay, here's the amplifier removed. It took a little bit to get it out. There's 4 studs that stick out from above, and you got to take the sheet metal nuts off. And this is the amplifier. Its filter cap. It's got a shield and the 2 output transformers. So let's remove the shield. Just twist these, give them a Few degrees twist. Should come right off. And it's pretty basic. We have 1, 2, 3, 4 resistors. 4 resistors for a stereo amplifier, yep. And then 2 capacitors. I'm thinking there's a connection to ground here, a chassis. That's probably where we're getting our shock from. These capacitors are probably shot to 0.01 at 400 volts. Printed circuit board construction, pretty typical of the later tube stuff. Before they switched to transistors, they were using tube sockets right on the PCB board. These are prone to cracking. This one's no exception. Here's 1, 2, 3, 4, maybe 5 of the connections of the tube there, out of the 7 or so. Same with this one and this one. Pretty basic. He is as basic as it gets. You got electrolytic, 3 capacitors. Oh, here's 2 more. 4 resistors. There you go. So what I'll do is I'll get on changing this. This needs to be changed, this electrolytic, for sure. This is not a good setup. I might just disconnect these speakers. I'd like to remove this amplifier, but it's all wired in. So yeah, I'll replace this with 3 electrolytics, and we'll put those where they need to be. So I was able to replace all 3 electrolytics on top of this PCB board. Kind of limited by height because of this shield. It restricts the height of the part I can use. So I couldn't stand them up. I had to lay them down. So here's the 100 microfarad at 16 volts, and that's out by its lonesome there. This one's a 47 at 160, and then 100 at 160. And these are power supply filter caps. Just placed them where they needed to be. This one I had to run a wire because there's really no option otherwise. And then I secured the caps down to the board so they don't flop around and bang onto the thing and vibrate. So that's done. Now here I have a look at this thing. I'll show you on my meter. Okay, here is the 100 microfarad at 150, and this one comes back at 260 nanofarads, and it's got a 9.4 kilo ohm ESR. The next one's 50 at 150. Let's get the wire here and I'll show you. There's that one. That one's 236 nanofarads and 13K ESR. The last one is the small one. It is supposed to be 60 at 10 volts. And let's see what we got here. This one's actually not bad. It's 3.9 microfarad and only a 1 kilo ohm ESR. Barely usable, but it's all garbage. Here's a 680 ohm 2 watt resistor that was in the power supply. It's between the 2 filter capacitors. And look what it measures. It measures 768 or so. 10% resistor. Oh, actually it's 20%, so it's still within tolerance, but I'm going to change it anyways. Look what happens when I hit it with heat. Put some heat on it. And it just starts climbing in value once it warms up. So 2 watt resistor is going to warm up in under load when it's being used. So quite a bit of drift on that resistor, so we're going to change it. Okay, now we got a couple of problems here. We have these 2 caps. These caps, this one here is located between the negative supply rail for the power supply and these 2 ground connections for our shielded inputs from the phono player. Okay, that's one problem. The other problem is we have this cap here, And this one's connected between the negative rail of the power supply and chassis. So that's where I was getting my shock from. I was getting my shock probably from both of these because, well, these are probably isolated from the chassis at the record player, which is no problem. But that's to reduce hum. This one here is probably the one that was giving me the electrocution, and I measured a full 120 volts when I measured between chassis and earth ground. So we got to do something about this. Now, from what I learned, I'm going to get some comments on this one. I don't know if, but from what I learned from some of my other YouTube content creators is the maximum size capacitor you can have between chassis and the circuit is 4700 picofarads, and that's to limit the amount of current that can go through that capacitor. But that's assuming the chassis is connected to earth ground, not chassis ground. So we don't have earth ground on this record player. It's just a two-prong plug, and this two-prong plug can be plugged in either way. So there's really no way to safeguard line and neutral will be connected always the same way up. Another problem with this plug is I have bare copper exposed here right at the end from, you know, it looked like it had an abrasion, a bad abrasion, and it got hammered up against something, and yeah, we got bare copper there. So what I'm going to do is I'm going to eliminate this cord and put a polarized plug cord in, and I'm going to tie neutral to the negative chassis, or not negative chassis, the negative power supply rail. That way the potential between neutral and the chassis can never get that high. It will never get higher than a few volts. And I'm going to replace these two capacitors with Y2 rated safety caps rated at 4700 picofarads instead of 10,000 picofarads each. I cut that in half. So let me do that mod now. Alright, so we got original GE tubes in this thing. Yeah, and looks like it has a date code of 1963. I'm not sure if that is a date code. I'm assuming it is. This is 50 DC4, which is a rectifier. Let's test it. Try that again. I screwed up. Okay. So let's give this a try. Way off scale. That's good. So we got two 35 EH5s. These are the output tubes, or the amplifier tubes. And a single stage, eh? And these are GE branded as well. And one of them has a date code. I was looking at it earlier. Where is it? It's obscured. I can't read it. Anyways, let's test this one out. Should be coming up. Good strong tube. Let's try the other one. I like to hold the switch down because then it shows me how quickly the tube warms up and how it comes alive. If it's really slow and sluggish, it takes its sweet time, then we know we got a weak tube. But these ones come up pretty good, and they pegged the meter, so I'm happy. Alright, now we have our amplifier worked over and assembled and back together. Got the tubes installed, they tested fine. So let's give this a test. Basically want to see is if the amplifiers work. I'm sure they do. They were working before when the filter capacitor was fried, but it should work a lot better now. Mainly I want to test to make sure if this cartridge is any good or not, because that can be an expensive game changer of this thing. If we have no working cartridge, it's going to drive up the repair costs. So let's plug this in and test it out. Okay. Give it a few minutes to warm up. Here we go. Sounds like we have some AC hum. Left, right, doesn't make any difference. It's got a loud hum. Okay, let's half volume, let's try this out. It's dead. Full volume, dead. Dead, 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 dead. So we're going to need a cartridge and a stylus. Okay, so what I've done is I removed the turntable and I jumpered the black and yellow together because I traced the wires back through that's the power switch. So what I'm doing is I'm shorting out the power switch to turn the power on, and here's my two inputs left and right. I'm going to plug this in and test and see if we have signal flowing through on these two. Make sure I get the neutral to neutral so I don't get shocked. Just allow this to warm up. Okay, turn up the volume. So we got both channels working. We just have a bad hum. I don't know if that's because of the neutral. Let's try reversing the plug. No, doesn't make any difference. Okay, so we definitely have a problem in that tone arm, or the wiring, or the cartridge is shot. I'm putting my money on the cartridge is shot. All right, let's have a look at this cartridge and stylus assembly. This is the 78 side. If you look on the top of the tone arm, there's a number embossed in there. It says 78, and then when you flip it over, the numbers facing up 3345. That refers to this needle. So this needle is your 3345 needle, and you can see it's intact. This needle here is broken off. You can see the base of it here, and this little red nub thing holds it in place. You can replace these needles if you sometimes they use a screw, but sometimes they use this. Let me try pulling that out. They use these plastic things. I can't pull that out like that. Here we go. It doesn't want to come. Very stubborn. You get a pull on it. It does not want to come out. How do you replace it then if you can't pull that out? Oh, I get it. It just slides in there. Okay. I've seen them with the screw. I don't know why they have this plastic thing here. Anyway, it's broken anyways. It doesn't work. Okay, so here's the bridge for the stylus pickup. It looks like it's broken. It's just flopping around in here. Let me flip it over. And you can see the stylus has these little wings on the sides, and it's supposed to fit over top of that nub in the bridge, but the bridge is broken. It's supposed to be like that. A little crooked, but you can bend it sideways. See, it's supposed to be like that. These typically track around, I don't know, about 8 or 9 grams. This one here has, oh, if you look here, here's the part number for the cartridge, 70TS, okay? And then it says here N8-3 needle. So that's the needle that you'd put on this side, N8-3. And on this side, it says N8-7 needle, and that would be the needle that goes on this side. So you can actually take this needle out. Can't pull on it. Anyways, that doesn't do us any good because this cartridge is foobar. We are going to remove it. So to remove it, there's a little set screw here in the end of the knob. Let's remove this set screw. And get my screwdriver to fit in. There we go. Back this screw out. It's under spring pressure too. Take it right out. There we go. I think I can get it now. No? Still has to come out. Okay. And then we can remove the whole assembly, spring and all. I don't give you much room to play around here. There we go. Spring. So, how do we do this? So these two wires will be one channel. These two should be the other channel, and they're marked right and left. So this is probably, it doesn't really matter at this point because it's just a crystal pickup. But this is probably going to be your live wire, and this can be your grounds, for example. So here we got, on the right, we have a green and red. And on the left, we got a black and white. So we can pull these off. They're just, oh, they are tight. Let me see if I can. They're just pressed on like that. There. And that's our cartridge. It's definitely broken inside if this is flopping around. I'm not going to open it. I can order these. I can order one on eBay. They have one on eBay, $65 US plus shipping. To get it to my door, it'd be about $100 Canadian. I don't know if the seller wants to spend that kind of coin on this little record spinner. I do have cheaper options. I got these. These are from China. These are ceramic pickups too. And we can see how this will fit. It's not going to fit. We're going to have to make it fit. But if it's a good fit for this application. Let's have a look at this. This is a Chinese equivalent. These were made for modern record players. Probably they'll be superior in quality over the originals because they're more modern and they have probably better characteristics. Now see, it has the dual needle. You flip the thing over. This is for LPs. That's for playing 78s. Okay. It's got the 4 connections. I think they even fit. So all I would need to do is mount this in this position, and Bob's your uncle. I think I'm going to do the foam block thing again, where I cut a piece of foam to fit in the head shell, and then I carve it out to fit the cartridge itself, and it's a snug fit. I could probably glue the foam into the head shell, and that would get everything back going again. That would be a real low cost repair for this. These are cheap, they're less than $5 each. This is not cheap because they don't make them anymore, and you're only looking at new old stock. If you can find new old stock, otherwise it's be used. And then if it's used or new old stock, you just might have the same thing here. It might not work because of its age and deterioration and stuff. It just might have given up. So we're going to go away from this, and I think we're going to go with this. Alright, so after about 5 minutes of whittling with a sharp knife, it's got to be razor sharp because styrofoam will just tear if you don't have a sharp knife. But created this little block of foam, carved it out of a chunk of bigger foam, and I cut it to fit within the head shell first. So it just fits bottoms out, and then I took the knife and shaved off what was excess, and then I started carving out the insides for the cartridge itself. And this is a press fit. You press it in, and it holds it fairly secure. I'm thinking though I'm going to glue some of this because I don't trust press fit alone. I'm sure you guys have your own ways of remounting cartridges like this. Maybe you should put down in the comments. I gotta get some better ideas from you guys. But I think this works pretty good. I don't know what you guys think. It's yeah, it's fairly tight. I don't think it's going to fall out unless somebody grabs it. So another thing you got to watch is the needle has to pretty much be at the same position the old needle was. So I put a couple marks here on the outside where the old needle was, and I think I'm off a little bit. If I put a straight edge across here, yeah, maybe a millimeter or two out. It's no big deal. I can push it forward. I can carve off a little bit of this foam here and push it forward. But I think that's good there, the way it is. Looking at it from, I can't turn this because it's. Looking at it from the side, I can see the needle protruding, and nothing else is going to drag and grind on the record. So I think we're good. I think I'm going to leave it like that. Now, probably what I'll do is I'll get a little dab of silicone inside the head shell just to mount this foam block so it won't fall out. And I think for the cartridge itself, I might do the same. Okay, what are we weighing out here at? This one is 5.07 grams. 2.55, so it's half the weight. Okay, something else I want to do here first is I want to check for continuity between our tone arm and the output to the amplifier. So let's see here, we got this black wire. This should be a ground, left ground, okay. And the other ground is a white, that should be my right ground. It's not okay, we don't have any continuity there. I'll have to investigate that. The green wire should be our signal for right, I think. No continuity there. And red. Okay, so red is working. Black is working. Okay, green is not working. Oh yeah, it is. Hang on. Green's working. And white was not working. Where's white? Well, that's weird. We got a short here. White. Okay. Red. Black. And green. Green. Okay, they all are working. Phew. Okay, looking over the mechanicals here, and I already see a problem. This is the power switch. Why is it loose? It shouldn't be loose. It's bouncing around. But this linkage here is supposed to be in here, I think, to turn this switch on and off. So that's in the on position right now. And this lever is telling it should be in the off position. So maybe, hang on. What's going on with this thing? Let's lift this up. Something's seriously messed up with this switch. Let's have a look at this. It shouldn't be floating like that. Yeah, these little things are supposed to be crimped over on there. This here is our switch action. Okay, off and on. So let's turn it off. Let's put it back together. I thought it was odd that the thing was always powered on and it wouldn't shut off, so that probably explains it. We had a bad switch mount here. Okay, so I can get this back down. Like that. Okay. Now that's engaged there. Now I need to fold those tabs down. Get a bigger screwdriver. There's one tab there. Tab there. There, it's secure now. Get the third tab. Third tab is over here. There. It's not coming out now. Alright, so the rest of this is just lubrication. Like all this old grease. Look at this stuff. It is nasty. So you can remove some of this old stuff and put fresh. This thing slides back and forth and it pushes on this little rod here, and this rod is what provides cueing for the tone arm. This has got, look at crud in here. So I'm going to take some time and clean and re-grease all this. I'm not going to show it because it would take probably forever on video. I'm just going to clean up some of this crap that's stuck here and everywhere. A lot of dust. Okay, so basically what I just did is all these sliding mechanisms here I re-lubricated with grease, this white silicone grease. It's not silicone, it's a synthetic, sorry. And any sliding areas I re-greased. I'm not going to go into full detail on how to do this because I have no idea myself. And it's been a long time since I worked on these old changers. But just got to make sure everything's clean and freed up. I want to go after the motor, and I was trying to figure out how to remove this platter because I lifted this little rubber donut here, and there is no C-clip in here or anything. But then I think, see, this mat is glued down. I don't want to rip that off. So, but look at that. You can just lift it right off with a Okay, so let's just take it right out. Take this out. Take this out, and there's our turntable. We can relubricate this bearing, and we can relubricate this bearing, and we can remove the motor and lubricate that as well. Okay, let's clean up some of this stuff here. It's pretty old grease on this. Look at that. Oh my goodness. Get rid of this. Now I just want to there we go. Now let's see if I can do this. Now we're getting it. That's basically all you do is just clean and re-grease anything that slides or rotates. Not bad in there. Okay, I think we're good. This is what I'm using is just this is a, what is this again? I forget. Tetrachloroethylene. It's the same stuff they use for dry cleaning fluid. It has the same smell and everything. It's kind of unpleasant to smell. It's not, apparently it's not very toxic either, but I'm not going to test any of that. We're just going to use it for cleaning, and then we'll get on with this. Okay, so that's nice and clean now. Put this aside. Next, we have the well. In here we have a bearing. And it's all goopy and greasy. So let's clean this thing up. They put a lot of grease on here. Just gonna let this soak. Let that soak for a bit, and then we'll get another plate in there. Okay, so I'll pull that one out. Okay, clean this one. And what else is down there? That's it. We're onto the base metal. Okay, so let's just wipe out this extra grease. Big gob of it. Clean that out. Nice. Pick out all the dust and grease. And you can see down there it looks nice and clean. Clean enough. Alright, we got another washer to clean. Looks like these washers are polished or plated with something. See, there's the one surface the bearing was riding on. Here's the other surface. Looks pretty good. I wonder if you could flip these over, and I guess you could. It wouldn't really make any difference. The thing you want to be careful of is any imperfections in these bearings, and you're going to get rumble. So, yeah, but I think I'll leave that alone. I'll put the same surface back up. Put a little bit on the back side. Put a little bit on top side. I'll grease the bearing up itself before I put it on. We'll drop this in place. Okay. Now I think sometimes they put foam in here. No, it's just grease. Can't see what I'm doing. Okay, give that another soak. Let that stand for a while. Okay, what I did is I took it outside and blew it out with compressed air. That makes it, gets it a lot cleaner. I'm just going to give it one more clean with the solvent. It's pretty good now. Yeah, that compressed air got rid of all that old grease, dirt, and oil. So let's pack it. And to pack it, we just fill up all this space between the balls in the cage. Just like that. That's plenty. And then we can put it back on the spindle. Okay, you can see it in there. Oops, get out of the way. You can see it in there. I dropped the bearing down in, and I put it face down, or the open end down. It doesn't really matter, I guess. I'd rather see the open end face down. That would keep the dirt from getting in there. But if dirt makes it in there, it's which way the bearing's orientated is the least of your problems. Okay, so let's just put a little bit on this. Let's give the shaft here some lube as well. There we go. Got a little bit of bearing noise. I don't know if you can hear that. Gotta remember, any bearing noise is going to make rumble. Okay, here we go. This is the motor. And this is 117 volts AC synchronous motor. Pretty standard affair. There's really not much going on here. If you've seen one of these, you've seen all of them. But these are pretty simple. And all you got to do is remove. Let's see here. You got to remove. Oh, that wasn't even very tight. Now, a lot of people probably have different opinions on this. You can spray oil or cleaner or junk or remover or whatever you want in these bearings. You can actually get in there and spray too. But I think the best way to deal with this is disassembly, cleaning, and then relubrication. Oh, that was loose too. Holy. And that was one of the motor mounts. Okay, what is going on with this? There's a screw here. Let's remove this. This is just holding that in place. See, that one was tight. Hang on. Let's remove this screw. Get this bracket out of the way. Okay, be gone. All right. So our one. Yeah, another reason I want to take this apart and clean it, because I can see all kinds of dust in here. See that? What fell out? Something fell out. And then it gives full access for cleaning the bearings. And we can clean the bearings, clean the dust. Okay, so let me get ready for this. Pretty dry in here. Okay, clean the shaft. This side. Yeah, it wasn't too dirty at all. Pretty good actually. Still want to get rid of that dust because that dust impedes airflow, and then, you know, that's not good for the motor. And I think I had dust on this side too. This thing's heavy. It's got those copper cage that they do for shaded pole motors. Okay. Now for lubricant, I'm just going to use 3-in-1. 3-in-1 is plenty. Got too much on there. I'll put some on this one. Trash on there. I didn't clean this. Another bad thing about dust is it gets in the bearings and then it creates wear. So yeah, just get rid of it. Okay. Now we'll have to align these bearings, otherwise it won't spin, see? So we'll do that when we tighten it down. Put this back together. Okay. Okay. Good indicator of how well the motor is lubricated, bearings are aligned, shaft is straight, clean, is how long it spins. The longer it spins, the better off you are, right? If you spin it like this and it goes bleh, it means the grease is all dried up or sticky, or you know, it's dirt. So just keep spinning it. I'm going to tighten these down. I think I got it. I'm going to get them tighter this time. I'm going to keep checking it as I tighten too, because okay, I think that is good. Perfect. Okay, let's tighten this one. Okay, put that back in. So when I took the record changer out of the case, I found this little piece of spring. It looks like spring. I don't know if you can see that. I don't know where it came from. I'm trying to find a spot where this came from. I don't see any wear marks on it. And it looks like maybe it broke off from another piece. But I'm trying to see. There's only, let's see. There is a leaf spring like that here. I don't know what that does. But I think it's all there. But I'll have a look around and see if I can figure out what that piece is from. This bail arm here is missing. 2 set screws are gone. I don't know where they went. Now, I'm going to try and find something here. It pays to keep old hardware, I'll tell you. Okay, so it looks like about an 832 size thread, but that's an 832, isn't it? It fits right in there like nothing. Let's see what else we got here. I haven't got any of this sorted yet. That's another 832. Is that? Maybe that is a 632. What about this one? Same thing. Oh, here's one. That's the correct size. And that looks period correct too. It's got like a hex on the end. Okay, we need another one of those. Right here. Oh yeah, I got a whole bunch of these. Here's another one, another one. Yeah, I'll go with these 2. They're just long enough too, I think. Yeah, perfect. Okay, I'm back in here one more time. I wanted to address that hum problem I had with the last clips I had when I powered it up. It was getting hum. That hum wasn't power supply hum because we fixed all the power supply problems. That hum was coming from high impedance decoupling from these two lines here go to the phono crystal pickup, and they were coupled to ground through a 4.7 nanofarad capacitor that I put in there. I took out a 10 and put in a 4.7, which is going down in value, which I shouldn't have done. So what I did is I took that 4.7 nanofarad out, I put it in a 100 nanofarad X2 rated safety cap. Now this will provide a low impedance path for ground, or chassis ground I should say, for the 2 phono pickups. So that should eliminate a lot of that hum I was getting. It sounded like a high impedance hum, but now that should be gone. Didn't do anything else. Everything else is left the same. One thing I did do is I hacked off the power connector and I installed a polarized connector here. You can't see it, but that is a connector. And the reason I want a connector there is so that on the back I now have a mounted power cord, and this is polarized, and this mates with this, and it only goes one way so that it's always connected correctly, and that will eliminate the shock hazard, and that's probably the #1 thing this thing needed. So I'm going to put this all back together. Let's give it another test. I've been doing cleaning and lube on the record changer, and it seems like it's working good now, especially since we have a working power switch. So I'm going to put this all back together, and then we can flip it around and we can test it out. Just a few words on serviceability on this thing. It's not very good. I'm not happy with their GE's design. They got sheet metal cut sheet metal. It's all sharp everywhere. You slice your hands up if you're not careful. There's sharp corners and edges and protrusions everywhere, and it's not really laid out for servicing. The amplifier is upside down. It's held by these 4 sheet metal nuts, and they're really difficult to get in there because there's a power output transformer in your way, and you can't get your hand in here. There's 2 of them, one up front here, which ain't bad, but there's one in the back here that's really difficult to get to, and the same on this side. And there's wires in the way, there's this transformer in the way, there's tubes in the way. It's really I don't know, there's much thought put into this. I guess you could take this cover, remove it. You'd have to take it from the other side and remove the screws, and you drop out, and then you have lots of room, but it's just a pain. Okay, and then another thing is these tubes are upside down, and they're hanging here just by the tube sockets, and I'm not pleased with that either. There should be a wire spring retainer to keep these from falling out, because if your tube socket goes loose, that's the only thing holding these tubes in. This wasn't thought out very well, I don't think. Anyways, but I'm just rambling. So I'm just going to put the back on now. I got this connector here to make it easy for the next guy. And I'm just going to put a piece of heat shrink over this to lock it in place, so it shouldn't come apart. Just gonna heat shrink this, and then we'll put the back on. And put this back on, hopefully for good, and be done with the innards of this. A couple screws and we're all done. Okay, let's give this a test and see what we're doing here. Load a record. So typically what you do is you just load a record and put the bail arm down, and then turn it on. You're still getting a lot of hum here. I don't know why the amplifier's got that much hum. Been through it and everything looks perfect. Even at minimum volume, I turn to maximum volume, I get a little additional hum, but it's not bad. And about halfway, we got our stylus is working. Balance, left, right, bass, treble. Has a lot of effect on it. So it seems to be early in the amplifier stages. So I think what I got to do here is, tone arm's locked down, is I think I hit the reject, and then things go into action. Okay, now at the end of the album, I'll put it on the end here. What it's going to do is it goes back to home. It's going to load the next record and go play that record again. But since there is no other album, it just shuts off. If there was another album on the stack, it would drop and play that album. So it's an automatic changer. The hum is really got me now because I'm out of ideas as to why it's humming. We have signal on both left and right. We've got continuity between everything. All my grounds are in place. Got a working power switch now, which is nice. What else to say? I do think I need to pull the platter off one more time and clean the idler. I think it's slipping because it goes quite slow when it's doing its mechanical changeover. It spins free enough on its own, but as soon as the mechanics kick in, it really drags down. So I think I have a slipping tire here, and the cure for that would be just clean it with some rubber renew. So if I short the inputs to each crystal input with a screwdriver, it makes no difference whatsoever. I'm set to about half volume. I also notice I'm picking up tones that are being fed through the power lines. I believe those are probably from the utilities, and every once in a while you can hear a tone, a warble tone, and that's all coming from power line. So I'm wondering what I can do to get rid of this noise. It's coming in from the power line. Maybe I need more filtering. I'm going to try putting it through an EMI filter and see if this stops or slows down or settles down. The motor here might have had some oil on it when I put it back together, and it might have transferred onto the rubber tire here. And another thing you got to pay attention to is this inside surface here needs to be perfectly clean. It can't have any oil. So I'm going to clean this all up, and I'm going to see if it still drags when it's doing its mechanical changing. Put this back. Part of the bearing should stay down there. Other than that, everything looks good. Alright, I did manage to find a schematic for this record player. It's very, very basic. What we have here is power input. Goes to the switch that is on the record changer, and it also feeds power to the phono motor, and then comes back out and goes directly to a DC, the 50 DC4, the rectifier tube. And when you turn the switch on, it completes the circuit for the filaments, so all the tubes come alive after 11 seconds. That's supposed to be it. And then once the 50 DC4 comes alive, it starts producing B+. We got a 125 volt source and 110 volt source, and we have our capacitor, filter capacitors, and our 680 ohm in between there. So that's all good and dandy. We've got a source on both of our output transformers, and we do have both channels functioning. Everything's working, and a 110 volt source goes into the tube. Now here's where I'm kind of confused. We're getting a hum, and I played around with the controls, and I noticed that when I turn this tone control towards the treble position, which would be up on both of these pots, because if I turned it down, I would be engaging the effect of this capacitor on the signal, which would mute the high frequencies. So turning to the left, it says bass, so what you're doing is you're muting the high frequencies. I turn it to the right, it's treble, and I'm actually letting it go through without any influence of this capacitor. So we're getting full fidelity when we turn it to the right fully. So this circuit's working, and when I turn it to the left fully, it does shunt the high frequencies to ground, which causes the amplifier to respond accordingly. So this ground is there and it's working. One thing I did notice is that when I put the balance completely to one side or the other, the noise goes down, and when I have it in the center, it seems higher. And same thing, regardless of how the volume control pod is, the sound is there. So ideally, when this is turned right down, it should shunt everything to ground, and there should be no noise, but we're getting something. So I think we have a loose ground here on these 4 pots, and for whatever reason this one's working, but this one is not. So I'm going to pull that amplifier out again and check the grounds on these 4 pots, and I think that's what my problem is. This capacitor here, it specifies as a 10 nanofarad. I took it out, put it in a 4.7. I don't think it helped any. I took it out, took that one out, and put in a 100 nanofarad, and I think it did help a little bit. It keeps the this capacitor is only for the shielded grounds on both inputs. Keeps them isolated from the chassis. Alright, so pull that amplifier out one more time, check for grounds on these 4 pots. Let's see what else I can do here. Everything else is good. Here's the depth capacitor that I removed. Denotes ground, denotes chassis. Yeah, so I changed this one 0.01 to 4.7 nanofarad as well. But this now has a polarized plug on it, so the neutral goes straight to chassis ground. Actually, it goes to ground, not chassis. There's two different ones there. So the neutral goes straight to ground on the record player. Okay, let's have a poke around here. What I have is the chassis out. It's all connected. Tubes are in, and we're going to have a little testing here. I have 100 nanofarad capacitor connected to the clip lead. I'm going to clip this to chassis ground, and we're going to have a poke around and see if we can figure out where that noise is coming from. Okay, let me plug this in. Oh, I'm going to in the isolation transformer because I don't want to be using it without an isolation transformer right now. So let's turn that on. Let's turn on the amplifier. And I reach around and click on the power switch. And we'll just wait for the tubes. Now I have a feeling all this noise that I'm hearing is coming in from the power line. And the reason is because I'm hearing modulation on it. And it's really odd. There's no other reason for it. Okay, so this is our input for the phono, right and left, and it goes straight into the volume control pot, and then these two are at chassis ground. So short that one out. So we know it's not coming from the input. It's got to be coming from power. Now, okay, this is interesting. Right here and here is our input. So as I test here and here, there's no attenuation whatsoever. But as I go through the chain of pots here, check the second pot, and I can hear it left and right. Okay, let's go to the third pot. Now I can pretty much mute each channel by touching the capacitor to it. So that tells me it's been picked up right here in this 4 inches. So we have a problem with what is that? That's those 2 little capacitors. Okay. That's a 220K there, I think. $220K there. So between here and here is picking it up. Okay, I got it shut off for now. I just want to check some of the continuity here on different things. This here should be my ground. So if I check all the way around here, this goes around and comes up here. Okay, so now I should have ground on this pot. No, actually I won't, because that is the tone control. No ground on that pot. Ground on pot 3. How come that's short? Okay, that's ground, that's expected. It's supposed to be ground here too, but it's not. Why is this trace? Oh, that's the balance control, okay. Balance control should have ground here and here, which it does. Okay, this is the volume control. And it has ground here and here, and it does. I'm beginning to think I might have a bad pot. Let me test some of these pots. This one's almost 2 meg, and that's what it's supposed to be. This one's almost 2 meg, that's what it's supposed to be. Got about a 1 meg there. Tone 500K. Okay, well that's 1 meg ohm, not 500K. And that's 1 meg ohm too. Beginning to think this pot is bad. Maybe they did change it to 1 meg. Because they're both equal. Let's try this one again. It's not equal. I'll have a good look at that pot. Alright, so that's it for this one. I'm going to wrap this one up. It still has a terrible hum. Can't figure out what is going on with that hum. I'll tell you exactly what I did here. I did take this pot out. Which one was it? This tone pot, and check it. It is not 500K, it's actually a 1 meg pot. Not that it makes much difference. This is a real high impedance circuit. You got a 2 meg pot here, 2 meg pot here, a 1 meg pot here. So you got a really high impedance, and it's picking up some stray signals and feeding it into the amplifier. I tried Adding capacitors to decouple the power supply didn't make any difference whatsoever. The other thing I didn't rule out is a heater to cathode short on one of these tubes, but I don't think that's a possibility either. I don't think I saw that. Everything's normal around these tubes except it's high impedance input, and it's picking up stray signals. It's working good. I'm going to wrap this one up here. I think it's going to go back to the owner, and he can play around with it. It's a nice little unit. Back in the day, when they made these, I guess it was, you're pretty lucky to have one of these, play albums in stereo. Alright, I'm going to wrap it up there. Thanks for watching, and we'll see you on the next one. Take care.